Hi, I'm Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. Subject code CS3352. Subject name Foundations of Data Science. Unit 4 Python Libraries for Data Wrangling. The topics to be presented here are data indexing, data selection. First, data indexing and data selection. A series object acts in many ways like a one-dimensional numpy array and in many ways like a standard Python dictionary. It will help us to understand the patterns of data indexing and selection in these arrays. The different kinds of ways are series as dictionary, series as one-dimensional array, and indexes LOC, ILOC, and IX. Series as dictionary. Like a dictionary in Python, the series object provides a mapping from a collection of values. Here, for example, data is equal to pd.series of and the values are printed 0.25, 0.5, 0.75, 1.0, and their indexes can be written as index is equal to A, B, and C and D. So it should be written within single quotes because it is an alphabet. If we print data, the data and its corresponding index will be printed like in the output that is shown on this slide. A 0.25, B 0.5, C 0.75, D 1.0. Next, we can access using this index, that is data of B. It produces the result in the bth position as 0.5. We can also use dictionary like Python expressions and methods to examine the keys or indices and values. Example 1. We can check whether A is in the given data or not. We can write A in single quotes in data. It evaluates to true. Second example, data.keys of. It prints all the values of the series index, that is A, B, C, D will be printed. And example 3, list of data.items of. It prints the results with index and its corresponding values. That is A, 0.25, B, 0.5, C, 0.75, D, 1.0. Like this, the index and its corresponding values are printed. Series objects can also be modified with a dictionary-like syntax. Just as you can extend a dictionary by assigning to a new key, you can extend a series by assigning to a new index value. See here in this example, data of E is equal to 1.25. So the new index will be added in the index table and the value will be added in the series, in the data series. Here if we print data, all the corresponding indexes and its values from A to E will be printed. We can understand that the E is updated in both the tables. A series builds on this dictionary-like interface and provides array style item selection via the same basic mechanism as numpy arrays, that is slices, masking, and fancy indexing. Slicing by explicit index, that is, for example, data A colon C, that is, it prints the corresponding index and its corresponding values from A to C. A is 0.25, B 0.5, C 7.75. This will be printed on the screen. Next, slicing by implicit integer index, that is data of 0 is to 2, that is from the 0th position to the first position will be printed. 0th position is A and the first position is B. So their index and their corresponding value are printed on the screen. A 0.25, B 0.5. Masking the series object, we can simply write data of data greater than 0.3 and data less than 0.8. The true values the true values for this expression will be printed, that is greater than 0.3 is 0.5 and less than 0.8 is 0.75, and their corresponding indices are also printed on the screen. Fancy indexing can be used in series object. That is, we can write data a comma e. That is, the index a and its corresponding value is printed, and the index e and its corresponding value is printed. Eighth value is 0.25 and eighth value is 1.25. Next one, indexes. Pandas provide some special indexer attributes that explicitly expose certain indexing schemes. These are not functional methods but attributes that expose a particular slicing interface to the data in the series. Here, for example, data is equal to pd.series of a, b, c, index is equal to 135. So the corresponding index and their values can be printed. That is 1a, 3b and 5c. LOC, the LOC attribute allows indexing and slicing that always references the explicit index. For example, data.loc of 1 is to 3. That is the position in the value in the position 1 and the value in the position 3 will be printed. So the value in the first position is A and the value in third position is B. ILOC, this attribute allows indexing and slicing that always references the implicit Python style index data.iloc of 1 is to 3. That is, the values are B and C are printed. IX is a hybrid of the two, and for series objects it is equivalent to standard square bracket based indexing. Data selection in data frame object. The individual series that make up the columns of the data frame can be accessed via dictionary style indexing of the column name and attribute style access with column names. First, dictionary style indexing of the column name. Let us consider the older data frames for subject 1 and subject 2. Result is equal to, now we are writing like this, pd dot data frame ds colon subject 1 fds colon subject 2 result star ds plus. So now the output will be like this on the screen. Soy and his corresponding subject 1 mark, Ram 85 and Anu 92. Attribute style access with column names that are strings, that is result.ds. You can also, now the same output will be printed. Comparing attribute style and dictionary style access, that is result.ds is result star ds plus. If we compare these two attribute styles, it evaluates, this expression evaluates to true because the two different statements produces the same output. Like with the series objects, this dictionary style syntax can also be used to modify the object. For example, to add a new column, we can write like this: result star total plus equal to result star ds plus result star fds plus result. Now the output consists of the names and their ds subject 1 marks and the subject 2, that is fds marks, and the total of these two subjects will be printed on the screen. It is shown on this slide. Thank you.